All right. We got section 4.1, and it's actually chapter 12 in JV statistics. We are in probability. Probability has a tendency to be tedious. I wouldn't say difficult, just tedious. And as always, I always say this, stop the video whenever you need to. That's the point of it, so that I can say things perfectly, I hope, and you can go back and look at them, because sometimes seeing it a couple times is great. All right. What's great about probability is it comes from familiar things, and if it's explained well, it's actually pretty simple, and you'll see the pattern of it, but it takes time to explain all of it too. In the old days, you would start with a blank board, and I'd fill up an entire board with one problem. It was like just an amazing moment. Like, yes, I thought it was so cool. But with this video, do a little bit differently. So here's the scripted notes, and here's the answer key. So, all right, you see what sample space is. It's the list of all of the possible outcomes. Now, sometimes all of the outcomes is only 4, 8, 16, whatever. Sometimes all the outcomes is millions, so you couldn't list them all. But if you can ever list all of the outcomes, then getting the probability of something happening becomes very simple, okay? All right, and sample space size is, of course, just the number of possible outcomes. All right, so flipping a fair coin twice. No problem. That's pretty easy to figure out that there's 4 outcomes there. And I'll go ahead and circle that since we're on this problem, just so you can see it. Okay, it's pretty simple. Flipping a fair coin 3 times is actually going to be 8 outcomes, not 6. It's actually, because it's heads, tails, it's 2 to the 3rd. This is 2 squared, just to give you some background. And then 4 coins is, of course, 2 to the 4th. There's another cool pattern here, and you might want to point this out. Sample space is related often to Pascal's triangle. And of course, it's a little bit hidden in this case. So Pascal's triangle, let's check. You might want to write that down. This is kind of cool. Check this out. You got one way to get heads, heads. Getting a heads and a tails 2 ways. Getting 2 tails 1 way. 1, 2, 1. There's one way to get 3 heads. There's actually, let's see here, where do I have them here? 1, 2, 3. 3 ways to get 2 heads. And there's 1, 2, 3 ways to get 1 head, and 1 way to get all tails. 1, 3, 3, 1. Looks familiar, huh? Here we go. 1 way to get 4 heads. There are, let's see here, 1, 2, 3. Oops, where is it? 1, 2, 3. God, I got lost in there. 4. There's 4 ways to get 3 heads. So eventually you'll see this pattern. 1, you got 1, 1, 1, 2, 1. So here's row 2 of Pascal's triangle. Here's 1, 3, 3, 1. And then 1, 4, 6, 4, 1. If you notice, this adds up to 16, which is the total here. So how this reads, let me change colors here. And again, I'm doing more than the question asks, but there's 1 way to get 4 heads, 4 ways to get 3 heads, 6 ways to get 2 heads, 2 tails, 1 way to get 1 heads, and 1 way to get no heads, which is tails, 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 tails. So there is a pattern there. You don't see it in the way that I did it, but there is a pattern there. All right. So here's your 3 siblings. If you go down to this, okay, the gender of 3 siblings, and of course you see this very familiar 1, 3, 3, 1 pattern. 1 way to get all boys, and there are 1, 2, 3 ways to get 2 boys. 3 ways to get 1 boy, and 1 way to get no boys, which we call all girls. Okay. All right. Finally, we get into one that's not really a combination. It's a permutation. It doesn't say that on here. You don't need to know that word to get this, but it's a permutation. Elect a president and a VP from 4 choices. Clearly, you can't serve in both capacities. You can't be a president and a vice president. That would be kind of weird. It's called like a dictatorship. So you can tell that there's 4 ways to have a president, and the 3 left fight it out for the vice president. 4 times 3, there's 12 of them. So you're looking for 12 of them. Doesn't take too much common sense to get that. And of course, here they are. Okay. All right, now rolling a dice. This is the game Craps, which we may play in class together, which is kind of fun. Rolling 2 6-sided die. The most common roll is a 7. This is going to take a while to write down. The most common roll is a 7. This makes a nice little normal curve here, doesn't it? Kind of cool. Okay, and as you get away from the 7s, as you get away, it becomes less common to do. Okay, there's 6 ways to get a 7. So 1/6 of all rolls, 6 out of 36, or 1/6 of all rolls are a 7. Very common. Makes sense too, because it doesn't matter what the first die is. If the first die is a 6, then you have a 1/6 chance of getting a 1 to make a 7. If the first die is a 4, the second die, it could be a 3, you have a 1/6 chance of getting a 7. So it makes sense, total sense. Okay. All right. So you can write those down, but that's all sample space. And 36 is a pretty large sample space to try to calculate, but it's definitely doable. All right. My recommendation is if it's a small number of outcomes, go with sample space. Okay. So the next one, fundamental counting principle. This is a pretty simple idea. Okay. So when you do this, A and B is A times B, A and B. Okay. A or B is it's actually a little more complicated than this, but or basically means plus. For now, we'll just say A or B is A plus B. But there's a little more to it. We'll get to that later. There's a full formula. You might want to put it. It'll be the probability of A plus the probability of B minus probability of A intersection B. That's for later on. But for this part, don't worry about it. Or means plus and means times. That's the simple to start with, which is less than 1. No problem. All right. So let's do 2A. All right. 2A. You have this is the old going to somebody's closet and figure out how many combinations they have. You got 5 pants, 3 shirts, and 2 jackets. How many outfits do they have? That's going to be 30. Nope, multiply them together. Okay. Same goes for this. Same goes for that. No problem. Those are pretty simple. Okay. 2B, you have a class schedule, 1 of each subject. 3 science, 4 math, 5 English. There's 60 combos there. All right. And then 4 science, 2 math, 3 English. Same thing. And then you got this one. So all those are pretty simple. It's just multiplying. Okay. And then I think C is this is probably overkill. I could have done this a lot quicker. And then C is true, false. You've got 10 of them. If it's true, false, it's if you did it by hand, it'd be 2 times 2 times 2. There'd be 10 of them, right? But that's, of course, 2 to the 10th quicker, right? And then 8 multiple choice, A through E. So there's 5 options each time. Again, that's 5 times 5 times 5, 8 times, which, of course, is 5 to the 8th. Then if you have 8 true, false, and 6 multiple choice, you can see what I'm doing. True, false is, of course, is 2 options, true or false. And then A through D is 4 options. And you can see what I put together there, lots of combinations. I always crack up when I have 2 kids sitting next to each other and they don't know anything. And they both end up with the same right and the same wrong. They don't do well. And there was the exact same one. And I say, hey, is it possible you cheated? And they go, no, that's not what happened. And I would say, there's like 1 in a million chance that you have the exact same ones, just so you know. I always enjoy that one. That's always a fun one. Anyways, okay. Now let's go to D here, okay? So we got D, E, and F. So license plates, yeah, this is how you get so many cars out there. So 456 million cars you can have on the road, and they were all in the same freeway trying to block my way home the other day. Anyhow, but 3 digits. So there's actually 10 digits. 0 through 9 is actually 10 numbers, just so you know. So that's 10 to the third. It's 10 times 10 times 10. And then 4 letters. I don't know if we use all 26 letters. I don't know that. I don't know if we use 0 or O or not. I don't know all that stuff. So, but I'm just going to say 26 to the 4th, okay? If it's only digits, that would be 10 options 7 times, 10 to the 7th. And then if it's a digit, which is 1 of 10, then 3 letters, right? 26 to the 3rd, then 3 digits again. This is a pretty common one down here. This one's fairly common that we see in the cars today. All right. Now, 2E, a 10-digit phone number, area code 714. Well, okay, 714. If it must be 714, then there's only one option. That's a fancy way of saying one option. I don't know if I'd even, I don't know if I'd even put that, but I did, okay. And then there's the other 7 numbers, 10 to the 7th. Okay. And then the next one is right here is digits 9 and 1 not allowed. All right, fine. Then that would be 8 to the 10th. And the area code 714, but then no repeating digits. So again, this is a fancy way of saying one way. So you don't really got to count that. You could just start with no repeating digits. Well, I've already used 3 of them, so there's only 7 left. So it'd be 7 times 6 times 5 times 4 times 3 times 2 times 1, which we call 7 factorial. Okay? All right. Now let's go to 2F. Graduation line, 20 kids. Any order. If it's any order, that's 20 factorial. Okay, because there's 20 kids that can go first, then 19 that can go second, and then 18 that can go third, etc. And you end up, what this is this is basically 2.4 times 10 to the 18th power. I put the E there. That's what I'm talking about. Okay, it's scientific notation written out. Okay, and then the top 5 in any order. Okay, so the top 5 students in any order, that's 5 factorial, and then the rest would be multiplied by 15 factorial. And again, that's like 1.5692 times 10 to the 14th. The number is so massive, I had to do something different there. All right, and the next one, valedictorian, salutatorian, and any. Well, valedictorian goes first, only one option. The salutatorian goes second, only one option. And everybody else goes third. There we go. Okay. So again, pause the video anytime to do that, which is kind of the whole point of this thing. Go a little quicker. All right, now let's talk about combinations and permutations officially. We've been talking about it already. Okay, so the combination, a combination is when the order doesn't matter, and then the permutation order does matter. Now, I would write this down. Combinations are related to Pascal's triangle. And you guys are pretty familiar with that. I'm gonna write, right? 1, 2, 1, 1, 3, 3, 1, remember 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, remember that? You're pretty familiar with that. Permutations are not. I always think of permutations as a horse race. You got 6 horses in a race, then how many ways can the top 2 finish? That's 30. 6 guys can finish first, 5 can finish second, 6 times 5. Okay. A permutation is basically, and I always have kids write this down too. This is, I think it's always helpful. Permutations is basically a partial factorial. Obviously, there's a very fancy formula right here, but it's actually a partial factorial. So I'm going to try to do these. My answer is the classic answer, but I'm going to show you other ways to do it when I'm writing. Okay. First, let's do 3A, B, and C. We're just looking at if they're permutations or combinations. creating a passcode on your lock or cell phone. It's a permutation. They always say, what's your lock or combo? They should actually say, what's your lock or permbo? Because it's a permutation. You know what I mean? So, or permu, instead of combo or permu. Anyways, okay. We don't have that slang in our lexicon, but we should. B, choosing 4 female and 4 male students to be on the school site council. That's a combination, okay? Because there's no order. It doesn't make any difference. If you're chosen, you're on the committee. It's not like there's a specific order. And then C, selecting the toppings on your pizza, okay? That is a combination. We don't say, I'd like a pizza permutation. No, it's a combination. Does it matter the order of cheese, meat, salami? No, it doesn't matter. It's a combination. It's there or it's not. Okay. Just wanted to get that out. All right. Now, so there's a couple ways to do this. So we got 5, choose 2. I mean, this is the classic way to do it. Okay, this is the classic way. Couple other ways you could do is you could go to row 5 of Pascal's triangle, which I've memorized. 1, 5, 10, 10, 5, 1. I usually memorize up to 5. That's about right. Now this is 5, choose 5, 5, choose 4, 5, choose 3, 5, choose 2. It's 10, right? So that's one way to do it. You could do it the classic way. That's fine. The other way is, of course, get your calculator out. Okay, this is kind of cool to have. I'm going to go 5, then hit the math button right there, math, probability, and then go to combo, NCR combo, number, okay, 5 combination 2, and then hit enter, and you'll have, oh, I'm blocking it. You know, the answer 10. That's another way to do it, okay, which is fine. Okay. Now for 3E, 8 combination 3, 8 choose 3. How many ways can you have 8 things and choose 3 of them? Again, you could go to Pascal's triangle. I don't have row 8 memorized, so that would be a little bit harder for me. So I might go to my calculator and do that and go 8 math probability, a little bit of work. 8 choose 3. Whoops, I missed it. Go back again, try again. 8 choose 3. Okay. And it's 56. Okay. You could do it that way. So that's fine too. All right. Now for 3F, 11 combination 9. Again, I don't memorize row 11. So I'm probably going calculator, although you could do it this way too. So I'm going to go 11 combination 9, 11 math probability combination 9. All right. And that's 55. Okay, 11 choose 9, 55. Okay. Yeah, the answer there. You can do the long way too. Now, the permutations are pretty quick if you do them a different way. I like my little way better than the classic way, although it's not always practical. Okay, so 3G, I'm right down here. 5P2, you got 5 horses in a race. How many ways can you the top 2 finish? That's going to be 5 times 4, which is 20. Okay. And then H is, so it's the first 2 of 5 factorial. This is the first 3 of 8 factorial. So it's 8 times 7 times 6. Now, this one is not real practical to do it that way because I don't want to do the first 9 of 11 factorial. For 3I, I'm probably going to my calculator. That's probably what I'm going to do. So let me do that, okay? So we're going to go 11. So your math probability NPR 9. Massive number, but there it is. Okay. All right. For this next one, how many ways can we assemble a basketball starting lineup given 3 centers, 2 forwards, and 7 guards? All right. First of all, I have to say, I'm talking traditional lineup. Don't give me that we're going to start 5 guards. We're going to start, you may not even know this. The traditional lineup is 1 center, 2 forwards, and 2 guards. Okay. So my bad for being a traditionalist, being an old person. Okay. So 3 centers, we're going to choose 1. 4 forwards, we're going to choose 2. And 7 guards, we're going to choose 2. Put that together, you get that. And again, you can do that on your calculator. I've already shown you how to do that. Okay. J, let's go to K next. Okay. Getting beeping in the background here. K, how many ways can we select lottery numbers for Powerball? 5 numbers from 1 to 69 and 1 from 1 to 26. Okay. So again, this is combinations because you're not going to reuse these numbers. So, so if you're going to go 5 from 1 to 69, there you go. 69, choose 5 of them. And then 1 to 26, 26 choose. By the way, 26 choose 1 is simply 26, obviously. Okay. Put that together and you get a big, old, huge answer. Okay. And then L, how many ways can we select lottery numbers for Fantasy 5? Any 5 numbers from 1 to 39. Easy. 39, choose 5. And there you go. And again, doing your calculator, that's fine. And then M, how many lines can be created from 11 points from geometry? This is kind of cool. It's kind of a fun activity to actually do, but it takes a while. Remember, 2 points make a line. So you got to put the points all spread out. But if you do that, it's 11, choose 2. There's actually 55 lines. It's kind of a cool problem to do. It's a fun geometry problem to sit there and mess with it. So, all right, we're on N and O. Okay, there are 10 shows on your DVR you haven't seen. Gonna get them right here. Oops, on the right. Let me change colors here. Go blue. Blue. Okay, there are 10 shows on your DVR that you haven't seen, but you only have time to watch 3. Okay, how many different choices of episodes can you watch? Well, you got 10. You can choose to watch 3. Now, if you are particular about the order, order, most things are a series now on Netflix. So there's an order to it. So that's going to be a permutation. So it's going to be, you're trying to watch 3, so you can, so it's 10 times 9 times 8. And that's going to be that one right there. Okay. Now, there are 80 songs in your music library. You could only fit 12 into your MP3. Talk about an outdated problem. Let's just pretend like on your phone or something. I don't know. I just made the problem up. Anyhow, okay. So if you are, how many different choices of songs can you create? That's 80, choose 12. That's a huge, remember, that's basically rounding 6 times 10 to the 13th power. Okay. And then if you're particular about the order, that's 10p12. That's the first 12 of the 80 factorial. That's a massive number. Again, it's going to overload your calculator. It's going to go scientific notation on you. Okay. All right. So next one, understand and evaluate number 4 here. Probability. Okay. And we're going to go ahead and try to figure these out. Remember, probability is number of outcomes that you want divided by the total possible. Okay. What you want is the numerator, the total possible is the denominator. All right. Let's see what we can do. Let's check it out. Okay. 14 people are playing Mafia, where 1 person, not you, is the Mafia. What is the probability you catch the Mafia on the first try? This is a really fancy way of doing this. Most people are going to go, well, if there's on the first try, that'd be 1/13. I mean, not real hard to figure out. Okay. And the next one, after 3 unsuccessful rounds, what is the probability you will catch on the next round? Again, you're probably just jumping to this right away, although I put all the math out for you. You're probably just saying, all right, well, we're now down to 1/10 because I've been successful 3 times in a row. No problem. Okay. Let's go to B here, 4B. 3 of your 18 coworkers are spies. Everybody thinks they have a spy in their coworkers who's reporting to the big people. You know, this has been going on for forever. Okay, now you interrogate 3 of your colleagues. Interrogate, that's a rough term. You talk to, maybe just whatever. Okay, what is the probability you interrogated all 3 of the spies? Not real good. That means of the 3, you chose all 3 correct. And then of the 15, you chose none. Okay. And divided by 18, choose 3. Okay. By the way, this whole thing is pretty simple. It's 1 on top. Okay. There's only one way to do that. You go 3 for 3. Okay. So, all right. And then what's the probability that you integrated at least 1 spy? Oh my goodness. At least 1 spy. Okay. That's tough. Let's see, I gotta cut this out. It's right here. Get that a little better for you. Okay. At least 1. That means you got 1. You chose 1 and you missed on 2, or means plus. You chose 2, okay, and you missed on 1, or you chose all 3 and you missed on none, divided by 18, choose 3. Wow. Pretty good chance, 44% chance. Okay. This kind of stuff is too difficult for a test, by the way. So don't worry about that. I always go crazy on the notes here. All right. And then C, 10 cards, 4 of which are winners. So small deck of cards. You get to pull 3 cards. All right. So there's 4 winners. I got 3 cards. You win the grand prize if all your cards are winners. What are the chances you won the grand prize? Goodness. So of the 4 cards, you chose 3 of them. Then of the remaining 6, you had no non-winners. Then you're going to divide it by 10, choose 3. And it's about a 3% chance. Not a real good chance. Okay? By the way, there are other ways to do this, but I'm not going to get into that here. You win some prize if you get at least 2 winners. At least 2. So get this better. At least 2 means you got 2 or 3. So of the 4, you chose 2. You see that? And of the remaining 6, you got 1 of those. Or means plus. Or of the 4, you chose all 3. Of the remaining 6, you chose none. Divided by 10, choose 3. About 33%. Pretty good shot. Pretty good chance. 1/3 of the time. Okay. Cool. That stuff's a little, some of these are a little aggressive for what we're trying to accomplish. All right. Law of large numbers. Ah, yes. Item 5. This is such a simple concept that we put a name for. The law of large numbers talks about in the long run, the truth will emerge in the long run. So many examples of this socially, mathematically. In baseball, you see it all the time when a team comes out and they don't do well in their first 10 games and there's panic. But over a season of 162 games, people typically do not panic. Because the truth comes out, they realize it's all good. Okay. If you roll a dice 10 times and you get no 6s, you go, oh my gosh, the dice is messed up. No, you wouldn't say that, because in the short run, you might not get any 6s. But in the long run, if you roll 600 times, you're going to get about 100 6s. About. Not exactly, but about. Okay? And the law of, it's basically, it's the concept of, the law of averages is kind of a weird thing. We say there's no such thing. Recent events don't necessarily change it. Like if you roll a dice, like I said, 10 times and you get no 6s, it doesn't mean the dice is going to change and now become more likely to get a 6 to make up for it. It doesn't work that way. Okay. just kind of remains the same. Okay. All right, so 5A, the average span between major earthquakes in California is 23 years. Since we just had a major earthquake 2 years ago, there shouldn't be another one for a while. No, not the best answer is not necessarily. I don't like to put no because not necessarily. Okay. All right. In roulette, the odds of winning is 43.7%. I'm talking about if you did like black or red or something like that. Okay. Since you haven't won in the last 9 rounds, you must be due. No, you're not really due. It still remains 47.4%. You just got unlucky. Okay. So just kind of clear up some misnomers here. All right. Pretty easy idea. Okay. Joe is a 70% student. Jane is 90. Recently, Joe's been on a hot streak and he got 10 in a row right. He will outperform Jane on the next test. Not necessarily if Joe is still a 70% student. He may just have done well in recent events. All right. Average rainfall on our tropical island is 60 inches. Again, I'm on 5D here, 60 inches. Because it only rained 25 inches and 40 inches for the past 2 years, we can expect 115. So it'll average 60. No, not necessarily. I mean, it's funny. You often hear the term, this was a 100-year rain. A 100-year rain doesn't mean that we had a 100-year rain maybe 2008 or something in California. We had tons of rain one year. I forget the year. We had a ton of rain one year. And they call it the 100-year rain. But it did not mean that it'll happen again in 100 years. It means there's a 1/100th chance of it happening every year. That's what it means. So over thousands of years, it'll be every 100 years, about on average. Okay. All right, next one, distinguishable permutations. You've done this probably before, and you got this crazy formula here, but basically it's certain permutations. You just can't mix these letters up and say, okay, it's 8 factorial, because there's a couple of A's. Okay, because there's a couple of A's that messes it up. Okay, and so that's why it's divided by 2 factorial. Okay, and then the same thing, probability. I'm on 6B here already. Probability right there. Probability has 11 letters, but you got a couple of B's and a couple of something, a couple of I's. So two B's and 2 I's you're dividing it by, because it won't be a difference if you mix them up. It'll be the same. You can't tell the difference. Okay. So those are called distinguishable permutations. And then 6C is the same thing. We got 3 E's, 2 O's, and 2 K's, which accounts for that. All right. Okay. And then D, E, and F here. Trigonometry has 12 letters in it. And then you got a couple of O's, a couple of something else. There's 3 letters that repeat. Mathematics, you get the idea. And abracadabra, yeah, that's a very important mathematical word. And again, all those A's, there's like 5 A's. So it's you wouldn't be able to distinguish the difference if you did actual permutations. So you got to divide those out. All right. Now that's just a lot of probability, kind of random stuff, just to kind of get you going. We're going to get more specific skill-based things for testing in the next couple of sections. All right. Thanks for watching.